Hi everybody, Ljubomir here again, and today it's time to show you our new product, the 16 amp switch and power meter LoRaWAN. As it follows the philosophy of all of our products, so it's the protocol is fully open for integration into other systems. You can do quick POCs, you can test it with our enterprise, but that's not a must. So let's get into it. The moment you open it, you see how small the device is. So I'm gonna remove it from here and just leave it to the side for a second to show you what else is in the box. But we essentially have put a short user manual where the most important things are listed on about the device, you know, which terminal is for what is the function of the button on the back, what are the indications of the LED, and perhaps most importantly is the wiring diagram, which is quite easy. As you can see on the inside there is electricity meter. So this device is capable of both switching electrical loads up to 16 amps, which is around 3.7 kilowatts, but it depends on the voltage. But it can turn them on and off, and in the meantime it can also measure the electricity consumption in kilowatt hours with astounding accuracy. So I'm gonna put this to the side and show you the device itself. As you can see, the device is pretty small. If I compare it to my AirPods, you can see the difference. And the device, we made it intentionally that small so that you can install it into the backs of outlets and in hidden places. On the front, you see the basic wiring diagram, and you also on the back see a small button. So the wiring diagram itself, it's pretty easy to understand, but essentially through those two terminals here, you power it with AC voltage or DC. So that's important. You can power it with AC from 100 to 240 volts AC. And in this case, it can switch between 16 and 8 amperes. It's 8 amperes only for inductive loads, but all the resistive loads, like for example, electric space heater, it's up to 16 amps. If you're running a big motor, then it shouldn't exceed 8 amps. And for the DC voltage, if you power it with 24 up to 30 volts DC, then it can switch 10 amps. But as I said, the wiring diagram is pretty easy. From those two terminals, you power it, and then from those two terminals, you power the appliance that you want to power and to measure. On the back, you see a single button, and then the button itself, it has a few functions. It can trigger rejoin of the device, and it can also turn on and off the appliance. So let me wire it pretty quickly. Here I have prepared a cable which is from 220 volts, and here I have a light bulb, which is again crimped the same way. Follow the instructions about crimping. It depends on the load. You can use stranded wires in those terminals, but above certain amps we recommend using the ferrules. And something very important I want to mention right now, this is a solid core wire, and if you put it inside, it's important that first the isolation is not inside the terminal. This is critical. This is basic electricity 101, and it's important that you don't crimp it too long. So if I put it like this, you can see there is a pretty long exposed wire, so you shouldn't do this. It's 6 millimeters, the strip length of those terminals, but this is how it should be done. Essentially only the conductor inside and no insulation inside the terminal. But let's get back to the light. So as I said, here we have the 220 volts. It doesn't really matter which direction I put them, but just for the video I'm going to follow them. So the brown wire is the live wire. We insert them inside. Maybe one by one is going to be a little bit easier. So first and second, and then we tie the terminals. The terminals themselves are pretty high quality. They were manufactured here in the EU from a very well-known brand. So this device, we have not made any compromises. Literally nothing has been compromised about this device. And the maximum torque on the terminals is 0.4 Newton meters, which is quite high. But if you follow your local electric codes, you will know what type of wire to use. So I already wired the L and the N, and now I can wire also the bulb. So here you go. I'm gonna follow the same directions, but just gonna insert those, and then I will screw them just like that. And one more thing, if you're unscrewing the terminal, keep in mind that this screw is not gonna fall out. Don't worry about this. But I think all of them are tight. It's good to also make a test where you pull them to see if you have done it correctly. And now I'm gonna flip the device so we can monitor the LED, and I'm gonna supply with power. So the moment it is supplied with power, it should start joining the network. And according to the user manual, this should be a slow blink on and off every second. And then it's gonna join the network successfully and it's gonna show constant on. Or if it doesn't join the network for one reason or another, it's gonna start blinking fast. But let's power it on and look at the LED. Usually this lasts up to 10 seconds, the joining process itself. And now that it's constant on, the device has joined. So I have the light here, I have the button. The light right now it's off, as you can see. If I click the button twice, it's gonna turn on. If I click it again twice, it's gonna turn off. So this is the most basic things about this device. And then with the payload decoder, you can integrate it into any system you want. You can monitor the consumption of any electrical appliance up to 16 amps. And you can also turn things on and off, which is great. The use cases themselves, we actually designed the device for use case with space heaters in combination with our wireless thermostat. But the applications are endless. Basically, everything you can power on and off, and everything you want to measure, you can do it with this small device. And again, just for comparison with AirPods, you can really see the difference. That's it from me. If you have any questions, feel free to post them below, and we're going to make sure to answer. Thank you very much.